The last thing that's in this first section with like just the basics of derivatives is what does it mean for something to be not differentiable? And the best way to explain what is not differentiable to you is visually, to give you some pictures and talk about what are graphs that would have spots that are not differentiable. So there's actually three categories. So I'm going to spend a little bit of time on each category, talk about what you're looking for and why it's not differentiable. So the first category of spots on a graph that are not differentiable would be anywhere you see a discontinuity. Now, that discontinuity could look a lot of different ways. It could look like these first two pictures, which are, I call them like a gap or a jump in the function. I've seen some AP books call them jump discontinuities, where you have that gap between. The reason that you're not going to have a derivative at a discontinuity is if you think about what a derivative is, it's this tangent, the slope of the tangent line. You can't be tangent to something that doesn't exist. You can't just be touching and coming up with a curve if it doesn't exist. If there's a gap, if there's a hole, you're not going to be able to write a line that's tangent. So we have a lot of things that look that way, but all of these are for the same reason. So if you look at this third picture, this would be like if you have an asymptote. So anywhere you have an asymptote would not be continuous. Therefore, there would be no derivative. Or if you have like a floating point. So you could have a jump, you could have an asymptote, you could have a floating point. Anywhere a discontinuity happens, we would say that the graph is not differentiable. So if you're going to see problems on delta math where you actually have to list x values that's not differentiable, you're looking for any x value that creates a discontinuity. So the next category of not differentiable, kind of a fun one. It's if the graph has a sharp point. So sharp point, it could look like an absolute value graph. It could look like a graph. I've seen graphs that look like this. They look like a bouncing ball almost. Anywhere you have a sharp point, it's also called a cusp. I've seen that word used on the AP test is they'll ask about a cusp. A cusp is just a really fancy way of saying a sharp point. If you have a sharp point or a cusp, there is no derivative there because we think of being the slope of the tangent line. You could actually draw infinite tangent lines at a sharp point. So for example, I'll kind of use a couple different colors. If I asked you to draw a tangent line at this x equals c, you could draw it like this and you'd be correct. You could draw it like this and you would be correct. You could draw one going straight across horizontal and you would be correct. So because of that, because there is not one definitive tangent line, we say that it is not differentiable. You'll notice it is a continuous graph. I can draw this without picking up my pencil, but it lacks differentiability at that sharp point. And then the third and final reason that something could be not differentiable, and this one's the most difficult to see with the naked eye. Anytime you have a graph that has a vertical tangent line, vertical tangent line means, let me draw a picture here, that if you were to draw a line that is tangent to the curve, it would actually be drawn straight up and down. Here's the problem with that. Anything that is vertical has an undefined slope, or we would say no slope. Because of that, if there is a spot that has that vertical tangent line, we would say it is not differentiable. Doesn't happen very often. A lot of times it happens with like cube root graphs will have it. So like I think this graph right here is the cube root of x. But it is not something that shows up very often. It can be very difficult to see on a graph because it's just that slight moment when it's like straight up and down. And then the bottom just kind of summarizes, just because a function is continuous doesn't mean it has to be differentiable. The sharp points, the vertical tangent lines, those are continuous graphs. I never have to pick up my pencil, but it loses the ability to take the derivative at that sharp point or that vertical tangent line. If I know a function is differentiable, however, then it has to be continuous. So if it does work the other way, kind of like the converse, I think you talk about it in geometry. So that's a visual summary of how do you determine if something is not differentiable.